Hello, camera. Here it is. Okay, so regarding the Groundwater Information Network, the réseau d'information sur les eaux souterraines, please go to the next slide, Simon. So this is the general abstract of the project. In a nutshell, GIN is essentially a project dedicated to deliver groundwater data information through data standardization and integration techniques. But we are also working with the partners, with the provincial partners and territorial partners to integrate their data. And we're also working on at the international level with the standardization committees to bring new data specifications for groundwaters. And we are maintaining also links between ourselves and external international partners that will be covered later on during the presentation. So please forward. Simon, okay, the GIN team member, essentially, we are working in a small group. I'm leading the project. Simon is the technical lead, and we are assisted by Boyan Broderick, which is a scientific advisor who's working mostly on the semantic links that we can build using the groundwater information as a basic, and also Eric Boisvert is our technical advisor to help us do the important migration work that we have started this year. So next one. Very quickly to demonstrate, just to give a general situation of GIN. Basically, GIN is used to federate groundwater-related data sources from various kind of partners, and it offers to the end user a single point of access to standardized groundwater data. And we are covering the user base from provinces, territories, or international groundwater reporting agencies. And we are also meeting the needs of more local users like drillers that will consult GIN to get some information about specific water wells. Our approach generally is to bring heterogeneous groundwater data dynamically together. It is transformed and redistributed using a common data model. So for the end user, the information that is transmitted, whatever the partner is, will be coherent. We are mostly using international standard like Groundwater ML, which was developed by GIN to distribute groundwater information data. Of course, we are heavily relying on OGC data standards like WMS, WFS, and all the other link standards to distribute our mapping and data information products. And we are also using the ISO metadata standard to distribute all the metadata related to our data sets. Over that part, we are also managing the NRCan groundwater datasets that are created during the groundwater assessment projects or aquifer assessments projects. So we have developed a series of 15 standardized templates that are used to create standardized groundwater data that is distributed from GIN of the various groundwater project that NRCan is leading. So those are the essential background of GIN. The next one, please. So we have to modify our approach within GIN because of some constraints. The most important one was the human resources constraints. Over the past 3 years, some people left the team or were reallocated to other projects. So it has resulted in a decline of the workforce for the whole project, and we have to focus on the main components and the main parts of GIN to maintain it operational. With this human resource constraints, we also have an application infrastructure context, a very particular one. The current GIN application, which is online, is aging. So some of the components are overdue to be either refactored, replaced, or modernized, and we are based on some technical components that are difficult to upgrade. We need to follow the path of the government of Canada to host public-facing applications on the cloud infrastructure. So in late 2023, there's a modernization project that have started for GIN to move GIN to the cloud-based infrastructure. The Digital Geoscience Group within the GSC is responsible to assist our team to migrate GIN to the cloud, but we are on our side responsible to the development of the new components and make it compatible with the cloud infrastructure. So this is our main constraints in terms of modernization. Next one. So, and GIN also faced the following issue. With it was part of the Groundwater Geoscience program for many years, well, I would say more than 15 years. And for this new project cycle, EGP has set some instructions for GIN. We stated that GIN would be hosted for 1 year within EGP, essentially to stabilize the application, considering the human resources challenges, but mostly to assist GIN in the successful completion of its required cloud modernization initiative. So that was the essential goal of GIN within the EGP umbrella this year. And now for this current fiscal year, we have moved to Open Geoscience Network within the GSC. So this is kind of the last year of GIN within EGP, but we are still considered as an important client to host groundwater data that will be contributed by the various projects that will be demonstrated today. So next slide, please. In terms of structuration of GIN, one thing that we have defined is the minimal viable product. We defined this baseline in September, and it was for us very key to identify what needed to be simplified. For example, prepackaging the data files of groundwater data projects that are available within GIN will simplify greatly all the processes required to export to the end user our data. So instead of dynamically generating various file formats based on the preference of the user, we will simply follow the guidelines from a project like geo.ca that stipulates that the geodata should be exported as a standard file. So in that case, we have decided to export our data using geo packages for vector data and geotiff for raster data. That simplifies a lot the overall infrastructure that is required to support some of the operations. Also, we are looking to streamline the user interface, reduce the number of clicks to get the information or query it. And this is what we will demonstrate using the next couple of the slides. Just a very quick report about the status of the migration. We are still working with the Digital Geoscience Group to move GIN to the cloud. There are still technical issues that needs to be solved, but internally the development of the solution is at very good level. We reach about 95% of the MVP document that we have defined earlier in September. So next slide. Yeah, just to conclude on that in terms of responsibility. So for our group within GIN, we are developing the application, and the migration of cloud, as I mentioned, is the responsibility of the Digital Geoscience Group. And also for this current fiscal year, we have worked with a bit more limited set of groundwater data. So we have integrated groundwater monitoring data from provinces and territories, water wells from province and territories, and also the NRCan own hydrogeological data sets. Next one. And it will be now the turn. I'm leaving the floor to Simon Gagnon, who will demonstrate where we are in terms of gym development.
Okay, so as François said, most of our work is to migrate Gin to the cloud. But apart from that work that we do with the GDT team, we also did some development this year in this fiscal year. So we work on some core functionality of Gin. So basically the map viewer, we upgraded it to add some functionality to make it easier to navigate through the data sets. We added a new dataset dashboard that we use to show the borehole information and also the monitoring station information that you can see on this dashboard. We added a new updated view as well for the metadata, respecting the ISO 19115 standard as it's the standard for the GSC. We added some data search tool on the main page that makes life easier to search through the datasets that are available on GN. Like I do each year, I updated the web services, so the Sensor Things API, to make it available, the new data that we have for groundwater levels. And we make sure that the GIN services that is in the backend of the application is compatible with the new infrastructure to be able to generate the groundwater ML to outputs and to do some complex queries on the triple store that is behind GIN. So this is some teasers from the new portal. So basically, I want to say that we revamped the infrastructure behind, but what I can show from the first view of the portal is that we refresh some of the pages and the content, and there's a bit of science into the user experience. So I would say that we upgraded the user experience now on Gen, so it's going to be easier to find what you're searching for. And here's a small video here of the new map viewer that we use. So we can see like a panel that can be used to select the layers and also resort the layers if you want them on top, and see the information on the layers. And after that, you can query the maps and get to the new dashboard that we created to see more information on your data sets. So that's how it's gonna be. So the new dashboard, like we saw at the end of the video, is you've got the information on the right, but the most important part now is that all the action you can take with the data set will be regrouped into an off-canvas navigation on the left-hand side, and you will be able to download the data set in any format that you want and access the most specific data that you need. This one is for the borehole, so you can see the casing, the log diagram, and other information that you need for the boreholes. It's the same for the monitoring station for groundwater level as well. This is the new view that we use for the metadata. So as I said, it's compliant with ISO 19115. So all the information that you will have like in the XML file on geo.ca will also be available. I think it's more complete than what is available on geo.ca. So you can see, you can find easily and navigate through your metadata to see what you're looking for. So. Another task that I've been doing this year, it's like I said, it's updating the Sensor Things API. It's used for any application you can do with code, because you can integrate some snippet into portals or do some analysis on the data that is provided. The data in the Sensor Things API is mostly groundwater levels from 9 out of 13 provinces and territories that collaborate with GEN. So it's quite useful to have this plugin to see some trends. Something I wanted to say as well is there's a plugin developed by the RGM that is available for QGIS to view the Sensor Things API data into QGIS, and you can apply some filters as you wish to see the information that we provided through the Sensor Things API. GIN also take parts in other activities. Each spring, I compile data sets for the International Groundwater Resources Assessment Center. that is financially supported by UNESCO and the World Meteorological Organization. So they won the data for 2024. I compiled them for them, and they created a report that would be available later this year that we reviewed and we would probably make available on the portal as well. I think this is a good step to have a global overview of the resources for all the countries. We also have ongoing discussion with provincial and territorial partners to access their groundwater data. So if there's other data set that would be useful to share or disseminate on GEN, we integrate them into GEN. We links with the geodes.ca and OSDP as well to support the dissemination of GEN data through their platform. And we also take discussion with the permafrost team to maintain the permafrost information network that is also another portal and that is available, and we are currently doing an upgrade to this portal as well to present the information that they have to present. This is our contact information, so feel free to contact François, Létourneau, or me if you have any question for Jen, or you want to discuss about topics related to groundwater.